to Master T Math class. And in this live class, we want to continue from this topic in mathematics, which is circle geometry. In our previous class, we looked at some parts of the circles, understanding some part of the circles, and also we look at the first theorem, which is the angle at the center. The first theorem, theorem 1, says the angle subtended or the angle subtended by a chord or an arc at the center of a circle is twice that which it's obtained or it's subtended at the circumference of the circle. So this is the first theorem on which all other theorems hang around. So in the previous class, we look at the proof of this theorem. So here we can just look at it in the diagram. That is, we have, if this is a circle, we have a center O like this. So we might be dealing with either a chord or an arc. In each case, we still have something. Now let's consider this chord here. This chord AB. I mean the angle subtended at the center by this chord. Let's consider this obtuse angle here. This angle is at the center now. Now it's twice that which is subtended at circumference. Consider this as angle subtended at the circumference. So we can label this as C. So ACB is the angle at the circumference, while AOB is the angle at the center. So what the theorem is saying that angle AOB at the center is equals to 2 times angle ACB at the center. That is, when we put a letter here now, let's say ACB here is, the value is X, for instance. So the one at the center now will be 2x. So for instance, if the angle here is 30 degrees, for instance, angle at center will be 2 times 30, which is 60 degrees. So that's the first theorem, which is very important as far as circle theorem is concerned. So to have better understanding on how this is proved, you can look at the last class, in our live class, to see. So that is what we have there. Then let's look at the opposite of this. It's also true. That is, if this is the center of the circle and we have a chord. Now this chord subtend the angle at the center. And let's label this as AB. Then in this case now, we want to consider this reflex angle, not the obtuse one now. Now we consider this reflex angle here as the angle at the center. Now it also has the angle at the circumference, and that will be at this minor segment. So this part will be the angle at the circumference to this angle at the center. Okay, so that is that. That means here, if this is y, for instance, angle at the circumference is y, then angle at the center here will be 2y. So we have this for the first theorem, which is theorem 1. And when we understand this theorem 1, it will help us to solve questions related to this particular theorem. Okay, so let's look at the theorem 2. Theorem 2 states that All angles subtended by the same chord in the segment are equal. All the angles subtended by the same chord or arc in the same segments of a circle are equal. So we have this theorem number 2 here. Now let's consider the diagram. Looking at a circle here, and let's say this circle has a center hole. Now we consider a chord. In this case, let's use a chord. This chord here, the angle subtended by this chord in a segment of this circle. Now, this chord here has divided this segment into two equal this circle into two equal segments. So we have the major segment, the bigger part, the minor segment, the smaller part. Now, this chord here can form an angle at this part of the circle. That is, the two legs of the angle is coming from point A and point B. So we have this angle here. So understanding of this theorem is very important as well. So now, this same chord can form another angle. Let's have it this way. So we have this angle. We can still form more than two. So we can form another one by this way. We have it here. So it can even form more this way. We have it here. So what this theorem is saying is that all these angles here that is formed by this chord in one segment of a circle are equal. Now, the proof of this theorem here follows on the theorem 1 here. When we look at that, we shall see here now that this angle will be actually equal to each other. How? Now, let's draw a construction line from here. So when we draw a construction line here, we discover that we have angle at the center here, which is angle AOB. Okay, now if we label that as 2x, just as we have it here, angle AOB as 2x. So if we label it as 2x here, now it means that this angle here is at the circumference, of course, to this angle. So here will be x. This angle here is also at the circumference to this angle. So here also will be x. This also is at the circumference to this angle. Here also will be x. Also at the circumference here. Here also will be x. Now, they are all equal now. So we have this angle as x, this angle as x, this angle as x. So all angle formed in one segment by is a chord in one segment are equal. So let's take that as 2. Now, make sure you watch this video to the end. Now, we are going to apply this theorem in solving some interesting questions. So stay tuned and thank you. Now, let's look at something here. Which is the third theorem. We have theorem number 3. And in this theorem 3, the theorem says that angle subtended by a semicircle. Angle in a semicircle is right angle. So the angle in a semicircle is right angle. In other words, that means is equals to 90 degrees. So now, what are we saying by this theorem? Now, when we look at a circle, and we have the center of the circle. Before we can have what is called semicircle, semicircle means half of a circle, right? And before we can have a circle, it means the circle is divided into two. And the only line that can divide a circle into two is the diameter. So it doesn't matter how we have it. So this line might be drawn this way. We label it as AB. So this line drawn passed through the center here is a diameter. That means it has shared this circle into two. So 2 equal half, and we have a semicircle. Now, angles obtained by this diameter now in one part of the circle. So if you have it like this, formed by this, one leg is coming from A, the other leg is coming from B. So this angle here, what the theorem is saying now is that this angle is right angle. This angle now is angle 90 degrees. Some questions don't need to tell us before we know that will be, the angle there. So they will just draw the diagram by following the theorem that we know. Once you know that theorem, we'll be able to see. We'll be able to see from there and apply it. So it doesn't matter how we have it. Let's look at this circle now. If this is the center of a circle and a line is drawn this way, you might have it this way. So this line drawn is passing through this center. So that means it's a diameter. So any line that passes through the center is a diameter, and therefore it divides the circle into 2 equal halves. So if an angle is formed, let's say here by this diameter, this angle will be 90 degrees. So we don't have to be told. We just need to know that it will be 90 degrees. Now consider this triangle inside the circle. So we have something like this is drawn. Yeah, let's look at the application so that we will see what we are talking about. So let's consider this question here. We have this here as a, okay, all right. Hope I can still recollect how the diagram goes. So we have a center. Okay, let me draw the center first. I want us to see something here. So we have a line from the center this way. All right, and this is used to form a triangle in a way that we have this angle here, and this line, of course, is extended this way. Okay, let's see it this way. It's extended this way, and here we are given an angle here. So this is given as x, and this angle is given to as something. So let's say we have x plus 30 degrees, for instance. Now the question now says we should find the value of x. Now, when you look at this question now, the information supplied there is just that here is the center of the circle. Okay, now me looking at this question now, you'll be like, if you are not familiar with this theorem, you won't be able to see anything here. So you'll be just like, what is this? Now, but if I'm familiar with this theorem that angle at the center, angle obtained by diameter is 90. So now I will see that this line here is the diameter. So this angle should be 90. Then another thing will come to my mind here, because here I have a triangle whereby one side is extended. So all those things, they enter each other.